So finding areas, you need to be able to use the integration techniques from this chapter to find areas under the curves. So actually, a definite integral like this integral from a to b f of x dx, this is called a definite integral, right?
Mm-hmm.
So definite integral gives us area under the curve. For example, if f of x has this graph, say this is f of x, right? You know that
Yeah.
every one variable function has a curve as a graph, right? So let's
Mm-hmm.
say from A to B, it has a graph like this, and from A to B, it should be positive. F of x should be positive, or we
Yeah.
can say it should be non-negative, non-negative for all x in this interval from A to B. If this is
Mm-hmm.
so, if this condition holds that f of x is non-negative for all the values in this interval, then the definite integral gives us area under the curve, this area between A and B, between these two vertical lines and above x-axis gives us this
Mm-hmm.
area, this area. This area can be calculated by calculating the definite integral simply.
Mm-hmm.
So in the first example, he says that the diagram shows a part of this curve y equals to 9 over square root of 4 plus 3x. The region are bounded by the curve, the x-axis and the lines x equal to 0. X equal to 0 is here and x equal to 4 is this vertical line.
Mm-hmm.
As shown in the diagram, use integration to find the area of the region R. So as I told you, area of the region can be simply calculated by integrating over this interval from 0 to 4, integrate the given function. The given function here is the curve is 9 over square root of 4 plus 3x. This will give us the area under this curve, this region, area of this region R.
Mm-hmm.
So if you are able to integrate, you can calculate the area. This is simple. So what technique should we use here to integrate this? Find the integral.
Um, we
It is a
can
simple, yeah,
take
tell me.
3 out and then just do simple power rule,
Yeah,
general power.
yeah, yeah. That's it. So we can write it as 4 plus 3x raised to power negative 1 over 2. We move it to the numerator. And
Yeah.
3, you see that 3 is the derivative of the function in inner
Mm-hmm.
part, base function. So it should be available here for general power rule, and we will simply apply the general power rule 4 plus 3x from, okay, we will add 1 to the power and it will become 1 over 2 and it will be divided as well. So, we will have a 6 here. This 2 will be multiplied with this 3 6 times, and the upper limit is 4. So we will just apply the limits now. When we put 4, 3 fours are 12 plus 4, 16, 1 over 2. And when we put 0, it will give us 4,
Yeah.
4 raised to 1 over 2. So this is
Mm-hmm.
simply square root of 16 is 4, and this is 2. So 2, 6 are 12. So 12 is the required area under the curve. So this area is 12 square units.
Yeah.
So whenever you ask to find the area under the curve and between two limits, you need to find the definite integral like this.
Guys, can we shut Eleni up, please? Okay.
Is it clear?
Yeah, I understand. I understand.
So in this whole complete section, there is a just revision of integration techniques and nothing else. You know that if you know
Mm.
that this gives us area under the curve, this integral
Yeah.
gives us area, and there can be different functions to integrate. So In some functions, you will use substitution by a trigonometric substitution. In some cases, you
Hmm.
will use integration by parts. Use some formulas like we just did, integration by parts. There is a
Guys,
lot of noise from your side.
yeah, I know. No, no, guys, can you just take her to mom or something? I need to do this now. Close the door. Okay, we should be fine now. Sorry about
Ah, no, it's okay. So let's see another question. Now, there are two type of questions. One is to find the area under the curve. So this integral gives us the area under the curve,
that. Hmm.
area under the curve. And if you see, if you are asked to find the area between two curves, see the upper curve is f of x, and if the lower curve, which is a red curve, is g of x, and you are asked to find
Hmm.
the area in between, area of the region in between two curves, then what you will do, you will simply subtract, you will compute the integral,
Hmm.
subtract the lower curve from the upper curve minus lower curve.
Hmm.
This is the formula, simply.
Yeah.
If you will calculate this, then this will give you area between area of the region R.
Uh-huh.
So what is the upper curve? You have to see what is the upper curve is f of x, and what is the lower curve is g of x.
Yeah.
So you have to see what is upper curve and what is lower curve. Subtract lower curve from the upper curve, and you will if you will integrate this, this will give you area between the two curves.
Hmm.
Okay.
That makes
So
sense.
just like in this example, the diagram shows part of curves f of x and g of x, these two parts. So f of x is sine 2x and g of x is this function. And the the domain of both these functions, the part of the domain is from 0 to pi by 2. So the region is bounded, R is bounded by these two curves. Use integration to find the area of the region R. So area of the region R can be simply calculated as upper curve minus lower curve, like
Hmm.
this. Okay.
Yeah. That makes sense.
So f of x given is sine 2x, and g of x is sine x cos squared x.
Uh-huh.
Right? Now how to integrate this? Simple integration. You will
Um,
integrate them separately.
yeah, yeah, yeah.
Yeah. Sine 2x.
It is the same as sin x cos x, right?
No, no, no. You can just integrate sine 2x
Oh,
directly.
oh, yeah, of course, of course. Okay.
What is the antiderivative?
Cos 2x, right? Negative cos 2x.
Negative cos 2x. So the integration of this part is negative cos 2x divided by 2.
Yeah.
What about the second term?
Um,
Okay.
uh,
No problem. If you can write the integral like this, we will integrate in the next step. Can we write it as cos squared x times negative sine x dx? Or this negative sign is taken inside.
oh, yeah, yeah, true. Um,
So now you see the derivative of cos x
it's minus sin x. Oh, so it's just present,
is minus
so.
sign. So you can use the general power rule simply.
Mhm.
So add 1 to the power and divide by new power.
Yeah.
So if you don't understand directly, you can do it in steps. Just write them separately and then see what is the method. So
Yeah.
apply these.
Hard to
No problem.
focus.
Now apply these
Yeah.
limits. Put the upper limit. So cos 2 times pi by 2 will be cos pi, right?
Yeah.
So I can take this 1 over 2 outside.
Hmm.
Just cos 2x imagine that just cos 2x is inside. So apply, put pi by 2, then we will have cos pi. This will be cos pi minus cos 0, like this.
Yeah.
So if you know the value of cos pi, it is negative 1, and cos 0 is 1. Cos 0 is 1.
Mhm.
Okay. Again, similarly here, if we put pi by 2 here, what is the value of cos pi by 2? Cos pi by 2 is 0. Okay.
Yeah.
So 0
Obviously.
raised to power 3. Okay. And if we put 0 here, so you know the value of cos 0 is 1. So 1
Yeah.
raised to 3. So these are just
Mhm.
values. If you don't know the values, you can use your calculator.
Yeah.
Minus 1 will be minus 2 plus
Mhm.
1 over 3. And inside is only negative 1.
Yeah.
Now just add them. 2 will be cancelled and minus into minus plus. So 1 is coming from this part and negative 1 over 3. If you take LCM, so this will be 3 minus 1, 2 over 3.
Mhm.
This is the required area.
Okay.
Okay.
Yeah.
So let's go to the next. Now this is a complete exercise. Find the area. Now there are two type of questions. You can find area under a curve directly by finding this integral. The
Mhm.
limits will be given to you and the curve will be given to you. If you calculate this integral, this gives us area under the curve. If there are two curves and you're asked to find the area in between two curves, then the formula is upper curve minus lower curve,
Mhm.
and you will integrate again. These are two types of questions here.
Yeah.
So which question should we do? This is a practice, kind of practice of the integration. Just like, for example, in this question, 2e, find
Yeah.
the exact area of the finite region bounded by the curve f of x, the x-axis, and the lines x equal to a and x equal to b.
Mhm.
In this question, you have to find the area under the curve between these two limits from 0 to log of 2. So area
Uh-huh.
will be integrate the given function from the lower limit is 0 and the upper limit is ln 2.
Mhm.
So if you can calculate this area, this integral, this the value of the integral will give us the area actually. That's it.
Mhm.
So how to calculate this integral now? The question is same as we were doing
Yeah.
in previous exercises. Which uh, method will be used? What method will be
Um,
used?
can we do it directly and just make it negative x e to the minus x? Or do we need to use biparts?
Always remember that. Uh, See if the derivative of the power is available. What is the derivative of the power?
1 here, minus 1, I
One.
guess.
But we have an extra here. X is extra here. So what will
That's true.
do for of this x? So whenever there is a product gives you idea to use the product rule, and the product rule is called integration by parts.
Hmm.
Product rule of integration is the integration by parts. So which function should be taken as a first function and which should be taken as a second function in this case? This is
First,
algebraic and this is exponential.
because it's easier
Algebraic,
to,
yeah. Algebraic
yeah.
is taken as first function in case if it is together with the exponential or logarithmic function.
Hmm.
So take x as first function same, integral of the second function. What is integral of e to the power negative x?
Um, negative e to the power x minus x, yeah.
Yeah. So the integral is e to the power negative x, negative, okay,
Yeah.
minus integral of the derivative of the first function is 1 And the integral of the second function is this. Again, once we have also need to integrate once more. Okay, you muted yourself.
Yeah, sorry, the baby came back into the room.
No, no, it's okay. No problem. So we will apply the limits after overall integration. So I'm just integrating inside and putting the limits outside here. Is this fine?
Yeah, yeah.
So negative e to the power negative x minus into minus plus, and we have to integrate e to the power negative x again. So e to
Which
the power
is
negative x, same
right.
this
Yeah.
integral, right? And the limits are 0 to ln 2. Now apply the limits.
So
Let's take negative sign outside. Apply the upper
yeah.
limit first. ln 2 e to the power negative ln 2. Okay?
So let's just go -2 now.
Plus e to the power negative ln 2. This is the upper limit.
Yeah.
Now if we put the lower limit is 0. So put 0 in place of x. So first term will vanish because of this x, and the second term will give us 1 only.
Yeah.
So when we put 0, we are getting 1 only. You just need to simplify this, and that's it.
Yeah.
Okay. So negative. What is e to the power negative ln 2?
-2.
No, 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 no.
Oh, is it not?
This will give you 1 over 2.
Oh yeah, because it's negative. Oh yeah.
Oh, actually, this negative sign will give upwards, like using power rule. E to the power log of 2 inverse. I can write it like this. So that log and anti-log, these will be cancelled. So we will get 2 inverse. 2 inverse means 1 over 2. Is this
Got it.
fine?
Yeah, yeah, that's all good.
So this is 1 over 2 and this is 1 over 2. So we will get this only. Fine?
Yeah, that's all good.
Okay. So 1 over 2 minus 1 will be minus 1 over 2. And multiply minus inside. So the answer is going to be 1 minus ln 2 divided by 2, like this.
Yeah,
I don't know what is the answer. Let's see. Oh, that will be in the answer sheet.
yeah. Do you want to check it?
Ah, yeah. So this is the required area of the under the curve and
Yeah,
between the given limits. So any questions you can ask here?
no, that makes sense.
Any other question now you can ask me to solve any question from this exercise.
Is this all of the questions that exist here on 11H?
Yeah. There
Okay.
are many questions. There are more
Okay.
questions.
Yeah, yeah. Oh shit. What about 9? Can we even do 9?
Yeah, sure, why
Oh,
not?
how would you find areas of colors if it's below the x-axis?
Sorry, how do you find?
The area if it's below the x-axis.
Ah, area if it is below the x-axis. You mean question 7?
Yeah, for example.
Yeah. Yeah. You need to see what is the upper curve. It is negative of that actually. Area below
Okay.
the curve will be negative, but if we multiply it by negative sign, it will give us the same area. For example, if the curve is below the x-axis, then the area will be simply absolute value of the same integral. You take the absolute value.
Mm-hmm.
Yeah, yeah, yeah. This will give you
Okay.
the area of a curve that is below the x-axis. This area, for example, if this is f of x and this is x-axis, so area between A and B, and this is this area.
Yeah.
Just take the absolute value. So which
Mm-hmm.
question should we do?
Um, I mean, unless 7 R1 and R2 are the exact same. If they're not the exact same, then let's do 7.
7?
Yeah.
Okay, let's do it. Let's see. All the questions in this exercise are easy. You just need to understand. You just if you know which method will be used for integration, then
Mm-hmm.
these areas to find these areas is doesn't matter. It's very easy. So say that the diagram shows a sketch of the curve of this equation. So this is the given function,
Yeah.
right? In part A, find coordinates of the points A, B, C, D.
Mm-hmm.
So first step is to find these coordinates.
Yeah.
So you see, what are these points? A point, B point, and C
They're
point.
all roots.
These all are
Roots.
roots, exactly, or
Mm-hmm.
zeros of this function. So in part A, find A, B, C. A, B, C are zeros or roots of given function,
Mm-hmm.
right? So what we will do,
Yeah.
we will put y equal to 0 and find these points first of all. This is the method
Yeah.
cos x square root of sin x plus 1 equals to 0. So we will say that the product is 0. It means either cos x is 0
Mm-hmm.
or sin x plus 1 is 0. Okay.
Yeah.
So on which points, actually, on which points in radians, cos x is 0. Where is 0?
Pi
X is
over 2.
cos inverse 0. Yeah, pi over 2.
Yeah.
So x is one value of x is pi over 2. Are there negative values as well? Is a negative? Is a negative?
Negative, yeah.
Because it is on the left side of the y-axis, right? It is on
Yeah.
the left side. So a is negative. We also need a negative value.
Mm-hmm.
What about negative pi by 2?
Oh yeah, yeah, of course. Yeah. 2 pi away.
So
And 1 pi.
yeah, so cos is 0 on pi by 2 as well as at negative pi by 2. At both these values, cosine is 0. So you
Mm-hmm.
can get two values from here. Let's see
Yeah.
on the right hand
Yeah.
side, sine x is equal to negative 1 and x is sine inverse of negative 1. Sine is 1, sine is 1 on
Is
y-axis.
that the same?
Yeah, sine is negative 1 on negative pi by 2, 3 pi by 2 on these values.
Hmm.
Okay.
Okay. So we have
And
values now.
7 pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, right? So where are these points actually on y-axis here? Negative pi by 2 is here, 3 pi by 2 is also at this point, and 7 pi by 2 is also at this point, at the same point, same location. If the terminal ray of the angle is at this ray point, and point is initial ray is here at x-axis, then all these angles are here at red point. Okay.
Yeah.
These all are angles like this.
Yeah, yeah, yeah.
So we have got all these x values. So choose any three of them. A should be negative. So A is negative pi by 2. And you see that distance between these 3 points is almost same. A, B, and C.
Yeah.
You see this? So what are these points now? So we have found that A is negative pi by 2. B is what?
Pi by 2.
Yeah, pi by 2.
And then
And C is 3.
3 pi by 2, yeah.
These are the three required points. Now
Mm-hmm.
part B. Let's
Oh,
solve
and
part B. Where is D?
D as well
Yeah.
when x equals 0.
Yeah. When x is 0. Okay. So let's find D. So you will put x equal to 0 in the given function. So if you want to find the D, let's
Yeah.
put x equal to 0 and y is the required point. Okay.
Yeah.
3
3
cos
times cos 0 is 1.
cos 0 is 1 and sine 0 is 0.
Yeah.
So what we are getting from here? What are we getting from here? So D is 3.
Yeah.
Okay.
Right, easy
So
enough.
let's do. Are you okay?
Yeah.
Okay. Let's do B part.
Oh, they're using. Yeah, okay.
Yeah, we will use a substitution.
For,
Use suitable substitution. Find this integral. Sin x 3 cos x sin x plus 1.
yeah.
3 cos x square root of sin x plus 1. What substitution will we use here?
Sin x plus 1 equals
Yeah,
to u.
yeah. Equals to say y or u, whatever. Okay. If we differentiate this, then what will we get? Sin x, derivative of sin x is cos x,
Yeah. And 1
dx
disappears.
equals to dy.
Mm-hmm.
Okay. So
Yeah.
let's put this in the given integral, and the integral will be equal to, let's call it I. So I will be equal to the integral, let's take 3 outside. So it will
Yeah.
be y raised to power 1 over 2 times dy. Okay.
Mm-hmm. Yeah.
So the antiderivative will be y to the power 3 over 2 divided by 3 over 2 plus constant. And this 3 will be
Mm-hmm.
cancelled. And this will be 2 times y raised to the power 3 over 2. And y is equal to sin x plus
Yeah.
1. So let's back substitute here. Sin x plus 1 raised to power 3 over
Yeah.
2 plus 1 plus constant of integration. This is the required
Mm-hmm.
antiderivative. Do you have any questions?
No, that's all good. I'm still good on substitution.
Now show that the region R1 and R2 have the same area. So we will now compute the areas of the region R1 and R2 and find exact value of this
Uh-huh.
area in the form square root A, where A is a positive integer to be found. So we have to find these two areas. Firstly from A to B,
Yeah.
then from B to C. The function is same.
Mm-hmm.
Okay.
Yeah.
And we already know the antiderivative. We just need to put the limits now.
Mm-hmm.
So we have calculated the antiderivative. This is the antiderivative. And in part C, let's compute area of region R1.
Mm-hmm.
Area of the region R1 will be calculated as it is from A to B.
Mm-hmm.
And we will integrate the given function. And given function is 3 times cos x square root of sine x plus 1. Okay. And what is the value of a? It was negative pi over 2.
Oh,
And what was
yeah.
what is the value of b?
B
We
was
calculated in part A. B was pi by 2.
yeah.
And the function is same 3 times cos x square root of sine x plus 1. Now its antiderivative, we already know antiderivative is this 2 times. So we will just put it here 2 times sine x plus 1 raised to the power 3 over 2. And the limits are negative pi by 2 to pi by 2. Fine. Now just apply the limits. Let's take 2 outside
Yeah.
and apply the upper limit. When we put pi by 2, what is the value of sine pi by 2? It is 1.
Um. Uh, yeah. Can I just ask? So when you order them in like A and B, do you not put A on top and then B on the bottom?
No, 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 no. A is the lower limit, so it should be less than B. Okay, lower limit is always smaller than the upper limit.
Oh, okay. I see.
If
Oh, the
if you
upper.
cal yeah, yeah, if
I
you
see. I see. I
calculate
see.
in the reverse way, then the answer will be negative. You know
Oh,
this
okay. I
property.
see.
Integral
Yeah.
from A
Yeah.
to B is negative of integral from B to A.
Mm-hmm.
Okay, you can integrate in reverse way, but the answer will be negative.
Mm-hmm.
Let's calculate this. Sine pi by 2 is 1, and what about sine negative pi by 2? Its value is negative 1.
So, yeah.
Okay,
Yeah.
so
Let's see for the upper limit. Two
1
times.
plus 1 will be 2 times, sorry, 2 power
Yeah.
3 over 2.
Mm-hmm.
Okay, and what if we will put negative pi by 2?
It just cancels because it's two times zero.
Yeah, it will become 0.
Yeah.
Fine. So 2 raised to power 3 over 2 can be written as 2 square root 2.
Yeah.
So the answer is 4 square root 2. This is the required area of the region, first region
Mm-hmm.
R1. Do you have any questions?
No, that's fine.
So let's look at the question. He is asking us to express the area as this, like this square root of A. So can we
Mm-hmm.
express it as square root of A?
Um,
So
what we do? 4 squared plus 2. So
so let's
root
let
18.
yeah, yeah, yeah. No, 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 no.
Oh,
It
is it
is
not?
root 16 times 2.
Oh, times 2, not plus 2. Yeah, you're right. So root 32.
Yeah, yeah. You can take 4 inside, it will become 16, it will be multiplied with 2. Let's
Okay.
calculate the area of the region 2.
Yeah, I had a question on this. So you said take the absolute value, but does it change anything? Like, do you have to, or can you just do the
Actually,
limits and at the end you just make it positive?
no, no. Look, if we are integrating this from a to b, f of x dx, this gives us area under the curve if f of x is positive. If f
Hmm.
is non-negative, this will give us area under the curve. But
Hmm.
what if f is negative? What if f is negative? We will make it positive. Then how will we make it positive? By multiplying with a negative sign. If f
Okay.
is
Okay.
negative, then what is negative f?
Uh.
Negative f is positive. Okay.
Oh, yeah. Of course. Of course. Yeah.
It is like what we call reflection over the x-axis, about the x-axis. If we multiply a function by a negative sign, it will give us, it will be reflected over the other side of the x-axis.
Yeah.
Isn't it true? But the area of the region will
Mhm.
be same. The region will be reflected, but the
Yeah.
area will be
Yeah.
same. So we will we will just take the, that's why I'm telling you that the area will be same if if we take the absolute value. So area of the region 2 is
Mhm.
the same integral. Now region 2 is from which point to which point?
From pi by two to no, from 3 pi by two to pi by two.
Yeah, from B to C.
Mhm.
Okay. From B to C. So this will be from B to C, the
Yeah.
integral of the same function, same given function, 3 times cos x square root of sin x plus 1. And we will take the absolute value in order to make it positive. This will be negative, so we will make it positive.
Mhm.
Let's see whether it is negative or not. What is B? B is pi by 2 and
Yeah.
C is 3 pi by 2. And this function, whatever it is, put it same. And we know the antiderivative already. What was that? 2 times sin x plus 1. Just put the same antiderivative. 2
Yeah.
times sin x plus 1 raised to the power 3 over 2. And the limits are pi by 2 to 3 pi by 2. And we will take the absolute value of whatever it
Okay.
comes out, whatever the number it
Mm.
is. Apply the limits. What about if I put 3 pi by 2 here? What is the value of sine 3 pi by 2 is negative here. It will be negative 1
Mhm.
plus 1. It will be 0. So 2 times 0. What if I put pi
Uh-huh.
by 2? So sine pi by 2 is 1.
Those ones you end up with. Oh, you end up with just the same thing. Okay.
Yeah.
Mm.
Okay. So 2 times 3 by 2.
Yeah.
So you see, this will vanish and the answer will be 2 raised to the power
Four into
5 pi by 2. So
oh, but
let's
negative. Oh,
have
but then
absolute, yeah, 2
yeah.
times 2 is square root 2, and this will be 4 is square root 2, and this will be 32 square root 32.
Yeah, which is the same as the other one. All right, got it.
Yeah, so hence area of the region 1 is same as area of the region 2, and it is
Mhm.
like square root of 32. It is square root of a, so a is 32.
Uh-huh. Okay, that was a good question. That was a good question. A little bit of substitution in there.
This 9 is
Um,
also same. 9 is exactly the same.
how do you have to like move the x-axis up and just do your own x-axis, or 'cause how are you finding the region?
Which region? In 7?
R one and R2 in question 9,
Hmm. In question 9, there are
like
two
covering the x-axis.
functions. There are two functions, the upper
Yeah.
curve and the lower curve.
Mhm.
So in first part, you
Oh,
have to
but
find A, B, and C. How to find A, B, and C now in this part?
you set them equal to each other and see at what points they meet,
Yeah, you have to find the points of
right?
intersection of these two curves. Yeah, points of intersection, common points. So equate them and find
Yeah.
A, B, and C.
But then how would you compute the region?
Sorry?
Do you still just take function? Do you still just take the upper function away from the lower function to find the region?
Yeah. This is the problem
Oh,
in which you have to find the second formula. Upper function minus lower function.
mm, okay, okay.
This is area because there are two curves. So region R1 is the area between two curves. In R1, you have to see that what is the upper curve and what is the lower curve.
Oh, they're
What is the
different
upper
every
curve?
time. Okay.
Yeah, upper curve is, this is the upper curve in this case. So because this is going up, right? And lower curve is this. In case of R1, for example, if you are writing the area of region R1 in this case, in question number 9, so what will be the area of region R1? It will be from A to B. Upper curve is
Hmm.
2 cos x plus 2, and lower curve is
Yeah.
minus 2 cos x
Negative two
plus
cos
4.
x. Hmm.
This is upper curve minus lower curve. This will be area of region R1. But if we are
Hmm.
writing area of region R2, then it is from B to C, right?
Uh-huh.
And upper curve is this one now, minus 2 cos
Yeah.
x plus 4. And lower curve is 2 cos x plus 2. And you will integrate this to get this area R2.
I see. Okay.
You got the point?
Yes, that is quite similar to the one that we just did. Mm,
So which question should we do now?
what about A when you don't know which one is the upper curve and which one is the lower curve?
8. Question 8.
For A, it doesn't. You don't get a diagram. So how would you know which one is the upper curve and which one is the lower one? Or you
He
just
say
look at the graphs. Yeah. Okay. Mind.
he says that in part A, on the same axis,
Mm,
sketch
yeah.
these two graphs. So you know sketching. Firstly, you need to
Yeah.
sketch both of them. So after sketching, obviously, you will know that which one is upper curve and which one is lower curve. And you also need to find
Mm-hmm.
the points of intersection.
Yeah.
Should we do it?
Yeah. Why not? I need a refresher on sketching graphs anyway.
Sketch the graphs. So sketching, first of all, let's find the points of intersection. For sketching, we need to make a table of values and plot them all on the same axis and join them to find the
Yeah.
graphs. Okay. Let's find out the common points of intersection. So for the points of intersection, you will put you will equate them, f of x equal to g of x.
Yeah.
So x squared equals to 3x minus x squared.
Hmm.
So it is 2x squared minus 3x equal to 0,
Yeah.
and x is common, 2x minus
Yeah.
3. So we are getting two values from here, x is 0 and x is 3 by 2
Hmm.
values. So these are the common points.
Yeah.
Now, in order to know, for example, you are not sketching the graphs. You're not sketching. Okay.
No.
For example, you know how to sketch. You know, huh?
Yeah. Kind of. Like x squared is just big bell. That's it.
Yes, yes. So you need to plot the graph in these limits, in between these values from 0 to 3 by 2, or from,
Oh, is
let's
that?
say, yeah, these are the points of intersection, common points. So you can solve it without
Mhm.
sketching as well. How to solve it without sketching? Just tell me point in between, in this interval from 0 to 3 by 2, any point. Let's say 1, x is
Yeah.
1. What is the value of first function at 1 and what is the value of second function at 1?
Oh, that's a good point. First function you have just one, and the other one you have.
Pulse
two.
function f of, yeah,
Oh,
yeah,
so
2. So,
the upper curve.
so
Okay.
which one is the upper curve?
G. Yeah.
So G is the upper curve. So you can solve part B directly without sketching as well. That find the area. The required area will be, we will integrate from 0 to 3 by 2. Which one is the upper curve? G. And which one is the lower curve?
Yeah.
This. This will be the required area.
Yeah.
Find this simple integration. G of x is 3x minus x squared. F of x is x squared. So we will just integrate
Hmm.
this and find its value. This is simple, I think.
Yeah.
Should I do it?
X minus 2x squared.
Should I do it?
Yeah. Yeah.
Yeah. Okay. So
Yeah.
what is
Yeah. So you
the
end up with
what is the integration of 3x? It is 3x squared over 2, and 2x
yeah.
squared is 2x cube over 3, and the limits are 0 to 3 by 2.
Hmm.
That's it.
Yeah.
So
Hmm.
put the whenever put we will put 3 by 2, it will be 3 by 2 squared minus 2 by 3, 3 by 2 power 3. And when we put 0, all will become
Hmm.
0. We will get nothing in that case. So it will
Yeah.
be 27 over 8 minus
Yeah.
9 over 4.
Hmm.
8 will be LCM. So 27 same. 2 nines are 18. So 9 over 8.
Yeah.
This is the required area.
Hmm. Right. I see. Hmm.
So
And then how
the
would
prop
you, if you had to for marks, how would you sketch 3x minus x squared?
yeah, yeah. 3x minus
Like
x
how would
squared.
you,
You will
how
make
do you draw
make a
it
tab
off of 3x minus?
like
Yeah.
this.
Oh, okay.
You will put values of x. Whenever we put 0, y is 0. If x is 1
Hmm.
over 2, what is y in that case? 3 over 2 minus 1 over 4, 5 over 4.
Yeah.
So in this way, you need to find some points.
Uh-huh.
What about
And then
1?
eventually just,
What about 1?
oh, we did one. It was like two.
Yeah. What about 3 by 2?
Um, I'm not sure. No, no, two.
9 by 4, I think.
Yeah.
So these are some values.
Hmm.
Either you if you have a graphing calculator, you can just type the given function and give the limits, it will give you the graph. Otherwise, you need to find these ordered pairs and plot
Oh,
them on x-axis and y-axis. Draw an x-axis, call it x-axis, call this vertical axis as y-axis, and say this is x equal to 0 here. This is, choose some suitable scaling. This is x equal to 1 over 2. This is x equal to 1. X equal to 1 plus 1 over 2 is 3 over 2. And what are the values you are
hmm.
getting for y? When x is 0, y is 0. So one point
Yeah.
is 0 comma 0, this point. When x is 1 over 2, y is 5 over 4. You have to see where is 5 over 4. This is
Hmm.
1 over 2, 1. 5 over 4 is how much? one quarter.
Yeah, 1 1/4.
So it will be where? Almost here, 1 1/4. Yeah, here.
Yeah,
So
yeah, something like that.
this is the second point, 1 over 2, comma 5 over 4. What about at 1?
Yeah,
At 1, the value is, at 1, the value
2.
is 2. So 2 will be some, with some height. This is 1 over,
Hmm.
are you getting? 3 over
Yeah,
2,
yeah,
and
I get what you mean.
here
I
it
get what
will
you
be
mean.
2. So this is 2 here.
And 2
And what about 3
so
over
then,
2? It is 9 over 4. It will go upwards like this. So join them together like
yeah,
this
2
smoothly.
1/4.
Yeah, join them, just join them. Whatever the curve is you are getting,
Hmm.
join them together, you will get a curve. So I was doing it quickly.
Okay.
You need to do it properly. You will get the
Hmm.
required sketch, right?
I know, I know. I got. Yeah.
So
Hmm.
if you have any questions, you
All
can
right.
ask.
So I'll see you on the weekend. I'll let you know how my test goes. Nothing. No, no. I understood. I understood. All right.
So
Thank you for the session.
test.
Sorry it was a bit loud, but
No, no, it's okay. I you are
test is
looking
tomorrow. I'm gonna
very you
now
are
and
looking
I'll.
very you are looking very tired. Take some rest. It's okay. Test will be very easy
Yeah.
for you. Just look into the test and see which formula is suitable. Okay. Then think for
Yeah.
1 minute. Just think for
I
one
will.
minute, two
I'll
minutes.
put.
You get the idea, then apply it. Okay. So
Mhm.
best of luck for your
All
test.
right.
See you.
Thank you.
Thank you.
See you later.